So what I was saying is we're going to have to check this a little more accurately now to find out what's actually going to happen. So what we're actually going to do is we're going to do something called the first derivative test. We're going to look at the slope either side of that point and find out what's actually happening, and then we can make some decisions based on that. Now, to go to this summary first before we do that, we know that if we get this sort of shape, then what we have is a minimum. Notice these slopes here are negative, and the slopes on this side, these are all positive slopes. Whereas this question here, if we get our maximum shape, notice we have positive slopes to begin with, and then negative slopes on the other side. Now, if we have this sort of shape, and I've sort of broken this up a little bit, the point of inflection we looked at earlier, we have this part first, and then this part second. These are all negative slopes on this side, and actually these are all negative slopes as well, if we were to draw tangents. And the other option is it could be just like x cubed. We could have our positive slopes to begin with, and then on the other side they could also be positive slopes. So if we have the same sign for our slope, then that means it's a point of inflection. So if they're both positive or if they're both negative. If we have a negative slope followed by a positive slope, we get a minimum. If we have a positive slope and a negative slope, we end up with a maximum. So let's go back and look, see what actually happens. So we've got to investigate either side of 0. We need to choose values that are very close. So things like 0.1 and negative 0.1. Now if it turns out that this value 6, if this had been f double dash of x had been 0, I would have chosen 5.9 and 6.1. Something very, very close. But remember we're finding slope, so we're going to plug these into the first derivative, which is what we had up here. So find out what the slope is, and it turns out, and you should check to see you agree with this, negative 0.24, and then check a little bit to the right, and we also get a slope of negative 0.24. So if we go back to our thing, look what happens here is two negative slopes, tells us it's going to be a point of inflection, and that should be our conclusion for this question then. Point of inflection because there was no sign change. They were both negative, it did switch from one to another. So it's going to be important that you can remember each of those cases. So when we do get the second derivative of 0, you can actually go back and check and then make a conclusion on what's actually happening. Now if you prefer, this is another way of summarizing that data. If we check the slope either side of a possible point of inflection, if both sides are the same, we're going to say it's a point of inflection, both positive or both negative. If the smallest x value is negative and the largest x value is positive, and really what I should say here is if the smallest x value has negative slope and the largest x value has positive slope, then it is a local minimum. And the reason you can remember this is, just draw yourself a little picture, negative slope, positive slope, join them up, and you can sort of see that we get that minimum shape. And if the smallest x value is positive slope, so something like this, and the larger x value has negative slope, like this, and then we should be able to fill in the gaps as well, and you can see that you can get a maximum. So if you're copying those definitions, make sure you add the word slope in there, it's negative slope. But that's your little summary, or if you prefer, that's the visual presentation of the same information.